Take a piece of paper. This is parallel and perpendicular line segments. It's called a line segment because a line goes on forever. A line is never ending. When we think of lines, though, we think of a piece of a line, a part of a line. It has a beginning, it has an end. So it's a line segment. It's a segment of a line. Take a piece of paper. Fold the paper in half, landscape. And then fold it in half twice, portrait style. Landscape. Yep. And then open it up. On your piece of paper, I'm going to wait for quiet. On your piece of paper, I want you to identify two perpendicular lines, or two sets of perpendicular lines, and two sets of parallel lines. Remember, perpendicular lines, we indicate like this. Those are perpendicular. We indicate it by marking a right angle. Parallel lines, we indicate by marking two little arrows going the same way. On your piece of paper, find two parallel lines and two perpendicular lines. Take a look at the lines that you think are parallel. I want you to measure the distance between those two lines on two places, two perpendicular places. So if I think that these two lines are parallel, I need to measure at two places on the line the distance, the perpendicular distance between them. Okay, pull out your rulers. What do you notice about the perpendicular distance between your two line segments? Yes?
They are the same.
They are the same. So what about, so I measure here, from here that's 55, and from here to here that's 55. What about if I measure from here to here?
They'll be the same.
What about if I drew the lines out and then I measured way over on the side here?
What, like that? Like that?
No, if I kept drawing these lines out to the side, like that, what would the distance be over here?
It's the same.
Okay, so how can you tell if two lines are perpendicular? Yes. Or sorry, parallel.
You measure one line, you measure in one spot, and then you measure in the spot next to it and see if they're the same and if they're on things like that.
So you measure the lines. Parallel lines will be the same distance apart. At all points. Okay, what about if I want to draw parallel lines? How can I do that? Sorry. Yes?
You draw one line and make sure it's completely straight, and then
Does it have to be perfectly straight? What happens if I draw my line like this?
That's not fair. Then you just have to draw your line the same like that.
you have to measure your ruler. You have to measure the angle
I have to measure the angle?
of
Where?
because your line is slanted, so you have to measure how much the angle is from it. To get the angle.
I do not need to measure the angle. What do I need to measure? Yes. I don't even need to do that. All I want to do is draw parallel lines.
All you gotta do.
Yes.
You could just put the ruler up against the line and then draw a line on the other side of the ruler.
That's one way to do it, but let's say I want parallel lines that are further apart. Yes.
Keep your ruler like that, measure as much as you want down, make a little mark, and then move it over about 5 centimeters, or as much as you want.
Okay, so I'm measuring 35 millimeters.
Okay, now you move the ruler over and measure 35 millimeters.
Okay.
Make another little mark,
Okay.
and then now you line up the two marks with your ruler and draw a line.
Excellent. Two parallel lines. That's it. Okay, take a look at the perpendicular lines. How do you know? How can you figure out whether this line is perpendicular or not? Yes.
Got a right angle.
Okay, what's a right angle? How can I tell if it has a right angle?
90 degrees.
How can I tell if it's 90 degrees?
Put a protractor to it.
Hey, look, protractor. Okay, so I line up my protractor.
And then measure 90 degrees.
Okay, how do I measure 90 degrees?
You look on the protractor.
Yep.
Half the protractor to the top is 90 degrees.
Okay, so I'm hearing people talk and I don't want to. You are paying attention, please. This line and this line are 90 degrees apart, which makes that a right angle, which makes this line perpendicular to that line. Okay, now I want to draw a perpendicular line to my bottom line. How do I do that? Yes,
So the bottom line is already
Yeah.
down.
the bottom line that's already drawn. I want to draw a perpendicular line.
You find the middle of it, the line, and then.
Does it have to be the middle?
Oh, I'm thinking of a bisector. Yeah.
You're right. A bisector, it has to be the middle of the line. So if I was doing a bisector, what would I do?
You would find the middle of the line, and then the ruler.
So I measure the line. It is 130 millimeters.
65,
So I make a mark at 65 because that's exactly halfway.
and then you connect that line to the top of the other one, and you take your ruler, and you draw a line straight. No, not like that. You find 65. Do you find 65 millimeters on the other line?
The other line isn't the same length.
It's not?
No.
Yes.
You could and you can find the half of that one, and then just draw it from there.
Yes.
Draw it straight out.
Yes.
Draw a line completely vertical from the dot.
No. It's I know it now.
Yes.
You use the protractor to measure 90 degrees, and you do not use a straight line because the line is actually on a slant. So if you draw a straight line, then it won't work.
Okay. So I need to, this is only if it's a perpendicular bisector, I need to find the midpoint of the line. I need to make a mark. That is going to be the center for my measurement. I take my protractor, I line it up on that center, I make a mark at 90 degrees, and I draw my line. Here's a question for you. Forget the bisector part, but if this line, if we're going to call this, let's A, B, C, D, E, F. If line EF is perpendicular to line AB, is it perpendicular to line CD?
Yes, it is.
Why? These lines, these two lines are the exact same line. They're just spaced differently, right? They're exactly the same, not in terms of length, but in terms of relationship to this line. Okay? These two lines will never touch. So if we look and we measure, see the line going through AB, which is perpendicular to AB, also happens to be perpendicular to EF. Yes? Okay, now let's say that I just want to draw a perpendicular line. I don't really care if it's a bisector. Yes.
Like your protractor, couldn't we just draw a line with a ruler or just a straight line and then measure it with the protractor with 90 degrees on it?
Okay, so I draw a line. And then I do what?
And then put the protractor in the end. And then you line up 90 degrees. And then you draw a line from the end there.
And I can really do that. Sorry, guys. I can really do that at any point. I can put my protractor here and draw. I need to make sure that my line is straight on the bottom, that my zero line's straight, but then I can do 90 degrees here. This line is perpendicular. And I can measure 90 degrees here.
I'll come back.
And this line is perpendicular. And I can measure 90 degrees here. I need to make a little mark on the bottom so that I know where I'm lining up to. And this line is perpendicular. And so on and so forth. Now, I've drawn all these perpendicular lines to the bottom line here. What can you tell me about these lines in relation to each other? Yes. They're parallel. How do you know? They're the exact same line, they're just spaced differently, and we can tell. How do we tell if it's a parallel line? Yeah, we measure them. So this line and that line are exactly 25 millimeters apart, and this line and that line, again, are exactly 25 millimeters apart, so those two lines are parallel. These lines, on this side it's 30 millimeters, and on this side it's 30 millimeters, so that line is parallel to this line, which means that it is also parallel to this line. And this line is 27 millimeters there, and it's 27 millimeters there, so that line is perpendicular, or sorry, parallel to all of them. Well, if I measure this, I have a distance of 55 millimeters between those two lines. And then if I measure it on this side, it's still a distance of 55 millimeters, which means that those two lines are parallel. If you have two parallel lines and a third line that is parallel to one of the other two, the three lines are parallel to each other. It's at the back. Key ideas for this section. Parallel line segments are line segments in the same plane that do not intersect. Same plane is just basically the same area. The perpendicular distance between parallel line segments must be the same at each end of the line segment. So this distance here equals this distance. Riley, can you grab me the, never mind, here it is. Computer's running out of power. Some ways to create parallel line segments include using a ruler and a right triangle, using paper folding. Ruler and a right triangle in your geometry set. I can use this because this makes my right angle. I can use this to draw parallel lines that are parallel to this one. Parallel. You can also use your protractor for that. Yeah, protractor and a ruler would be fine. This is just another way. Perpendicular line segments are line segments that intersect at 90 degrees. Some ways to create perpendicular line segments include using a ruler and a protractor or using paper folding.